Okay, I'm ready to get started. This is about ABG analysis, not necessarily interpreting the results that you get when you run an ABG, but as far as the machines and what you need to know, not only at the bedside, but also for NBRC questions. So when you're using a blood gas machine, if you're using the radiometer's ABL machine, it'll analyze your typical stuff. It includes electrolytes. It includes a hemoximeter that looks at your hemoglobin saturations. The iStat, I don't even know if you're seeing this around. This was used at Joe DiMaggio.
I've used those before,
Oh, you did? So they have a little cassette, you put the blood in and you get your results. You don't have to calibrate anything. It's already automatically calibrated, but they may have changed over. So Rachel, you're not seeing the iStat in NICU, Tijin? Okay. Pardon me. Errors that can occur prior to analyzing the blood gas sample. If there's air left in the sample, it changes the PaO2 and it can change the CO2. I don't remember if you recall this from your first semester of the program, but an air bubble has a PO2 of 159 millimeters of mercury. So if you leave an air bubble in a blood sample and the oxygen level is 100, the oxygen molecules will equilibrate. The oxygen will leave the air bubble and get absorbed into the blood. So you'll have a falsely high oxygen reading. So that's why you can't leave air in the sample. And with the CO2 in air, there's almost zero CO2 in air, but the blood has a CO2 of 40. Those two gas are the two pressures will equilibrate. CO2 will leave the blood and go into the air bubble. So it really messes up the values on your blood gas if you leave air in the syringe.
It'll look like the patient has a really great blood gas and they don't.
Correct. The second thing that can happen is you thought you hit the artery, but you really got the vein. And one way you can tell that you hit the vein, sometimes with patients that are stable, you'll just notice that the color of the blood is more blue instead of the bright red for well oxygenated. And the other thing is arterial blood has a lot of pressure in the vessel and it will pulsate up into the syringe and fill the syringe. If the blood is not pulsating up because you're in a vein, the only way it'll come up into the syringe is if you pull back on the barrel and it'll pull the blood into the syringe, even though it's in a vein. So have you seen that kind of a technique used? Like the therapist sticks the patient and then pulls back on the plunger to hurry up and get the blood into the syringe?
Not pulled back on the plunger, maybe like needle, like fishing for the artery.
That's what you've seen? Yeah, so I've seen it so often where, you know, they stick and then they just start pulling back and they get venous blood. So it doesn't pump in, you're probably in the vein. Another error that can occur is having excess anticoagulant. Some syringes have liquid heparin in them. Some syringes have dry heparin. What have you seen used in the hospital? Everybody's seeing dry heparin? Okay. Oh, okay. So dry heparin, you don't have to expel anything. But if it was liquid heparin, you have like a half a cc of liquid in the syringe. And the pH of heparin is 7.0. So guess what happens when you mix that with the blood? It really drops the pH. So if there's liquid heparin, you have to get rid of that before you draw the blood sample. And then the time lapse since sample collection. If you draw the sample and you can't get to the blood gas machine right away, it's recommended that you put the sample on ice if it's going to take you longer than 30 minutes to get to the blood gas machine. So I remember doing morning rounds when I was at Florida Medical Center, and you get there at 6 a.m. and the first 40 minutes, it's just drawing everybody's blood. And then you stop that and then you go and get report for the patient. So you're going from one room to the next, drawing the blood, and you stick it on ice so that by the time you get down to the blood gas lab, when you lower the temperature of the blood, you stop the blood from consuming the oxygen, because oxygen levels will decrease in blood if you analyze it after 30 minutes, after an hour, after 2 hours, you'll notice the amount of oxygen keeps going down. I can't remember what I wanted to tell you about this. So you have a blood gas with a PaO2 of 33 millimeters mercury. The oxygen saturation is 48%. Is that arterial or venous? Very good. It's venous blood. So what is normal O2 sat for venous blood? 75%. So if your saturations are around 75%, then you have venous blood. And this one's way lower. So we've got venous blood. And I'm using the ABLs, and you get your printout of your blood gas. You're going to notice the letter F in front of your oximetry values. And nobody knew what the letter F was, so I called the company and found out it stands for fraction. So when something's reported as a percentage, they put capital F in front of it for fraction. So FO2HB, 93.8%. It's telling you the fraction of hemoglobin with oxygen. Do you know what HHB is? Or if you can read my writing, it tells you. HHB, it's reduced hemoglobin. Do you know what that means when hemoglobin is reduced? Very good. It's deoxygenated hemoglobin is called reduced hemoglobin. Good job. And then, of course, the temperature corrected values, your P50, I'm sure you remember that. Prior to instilling the sample in the blood gas sampling port, it tells you wear gloves, we know that. Make sure there's no air bubbles. Putting an air bubble into the blood gas machine messes it up, as does a clot. Mix the sample in a horizontal position. This is critical for accurate hemoglobin and hematocrit measurements. So let me just explain that to you. And now the blood gas machine does the mixing for you, so you don't have to mix it anymore. So what used to happen is you have your blood gas syringe, and before you put it into the analyzer, you mix it up. So people would hold it like this and mix it. And when they do, all the heavy red blood cells go down, And then when they put the blood into the machine, it's messing up the hemoglobin hematocrit measurement. So, but if you hold it horizontal like the horizon and mix it, now it's equally dispersed all the way through. So, oh, really?
So you saying horizontally?
Yeah. But then even if they're doing it like this, don't they put it in the mixer, in the blood gas analyzer, and then the blood gas analyzer mixes it? So that'll correct what happened with the red blood cells settling.
They don't even really need to be doing it.
Right. It's probably habit. Oh, no. So shaking, if there are tiny air bubbles in there, it's going to just bring the air bubbles together and make one big air bubble, and then you're introducing air into the machine. So I would say no to shaking it. When you get values from the blood gas machine, some of them are directly measured, such as the pH, the CO2, and the PaO2. So you've got an electrode in there that's directly measuring those three things. Everything else, I need to explain. So the bicarbonate, calculated. Base excess, it's a calculation. Oxygen saturation, if you guys are using the ABLs, that has a co-oximeter built into it, and it is giving you a reliable oxygen saturation. If you were using the old blood gas machines, if you were using the iStat, it estimates what the oxygen saturation should be. I don't know if they still put this test or this question on the NBRC. You analyze a blood gas using the Severing-House electrode. And what would you expect for your value? I don't know, they come up with something stupid like that. And what they're looking for is another name for the CO2 electrode is called the Severing-House electrode. So that's been around probably 15, 20 years. I'm hoping they don't still have that on the exams, but there it is if you need it. Another name for a CO2 electrode in the blood gas machine, the Severing-House electrode. The oxygen electrode is called the polarographic electrode. And the way that it works is oxygen molecules will dissolve in a liquid, and that'll cause electricity to flow. With blood gas machines, controls have to be run because what can happen is if you're at Memorial Regional and you run a blood gas in the ABL, and then you take the whatever's left in the syringe and you go over to Broward Health and you put the blood into their machine, are you going to get the same results? Well, if you don't, there's a problem because that's what the state of Florida, they have so many criteria for people to have a licensed lab. And one of the criteria is you have to be running controls a couple times during the shift. So here it tells you one solution is run every 8 hours. And the solutions have to span the entire range of values. So one for pH, one for CO2, one for O2. And then like high possibilities, low possibilities. And then the results are plotted on a graph. And here's a sample graph. So this is showing controls run on the CO2. And every time the control is run, it looks like the computer's putting a little red circle. So everything looks fine as long as we're within 2 standard deviations. I need to put that in the chat. Where is my chat? So in the chat, I wrote control values have to be within 2 standard deviations. And for CO2, that's 1 millimeter mercury is considered a standard deviation. So here in the middle, you see 40 millimeters mercury. And when you run the control, it should be between 38, so 2 below or 2 above. So between 40 and 42 or 38 and 40. So that's 2 standard deviations above and 2 standard deviations below. If you run the control and it falls within that range, you're good to go. If you run the control and it's out of range, you have to do something. You can't continue to use that blood gas machine unless you have proof that you fixed the problem. So the typical problems could be that the electrode gets old, solutions dry out, maybe the little membrane needs to be changed. So those are examples of things that can go wrong with a blood gas machine. And now it's so automated, there's not a whole lot that you guys have to do. So other than somehow digging this information out of your brain to take your national exam, these blood gas machines are so automated. Like you don't have to get a vial. You don't have to warm it up in your hands. You don't have to make sure that you do the horizontal or the vertical. So it's all automated. A single incidence of unsatisfactory performance requires documentation of remedial action. And if you have an incident where your controls are out of range and you didn't do anything, you do get, the hospital gets slapped with a fine. And if it happens again, they can actually lose some reimbursement from Medicare, reimbursement from the Medicaid department, and it can result in loss of the laboratory's operating license. So it's a really big deal to document any numbers, fixing any numbers that are outside the standard deviations. Here's a list of things that can go wrong and make the controls not work well. Doesn't it seem obvious when you go through the list? Like, all right, so if I saw any of these on a multiple choice question, I think I could figure it out. There are calibrating gases associated with a blood gas machine. So when you're calibrating against a known concentration of a gas, like they're bleeding in CO2 from a little cylinder, they're bleeding in oxygen. Ooh, not with the ABLs, right? ABLs don't need calibrating gases. All right, I guess that's just the old machines. What about Broward Health doesn't have the ABLs on wheels, right? They have a blood gas room. All right, so next time you're in the blood gas room, look to see if the machines have little cylinders of gas that are used for calibration. And let me know.
That little thing, about
Is it in the back? It takes long for what? Oh, does it really? Wow. So big difference in the timing too. This is a test question that shows up on your exam next week. Try rerunning the control first before proceeding with troubleshooting. Because a lot of times it's all you have to do is the first value came out of range, just rerun the control. So that's always going to be your first answer. The respiratory therapist is running controls in the blood gas machine. The value for the CO2 falls outside the 2 standard deviations. What should be done first? Yay, good job. Should you run the control in another blood gas machine? No, that's not going to help. Should you add electrolyte solution or change the membrane? No, not until you rerun the control first. 3 times a year, I think somebody in the state of Florida sends controls to all hospitals. All hospitals have to run the control in their machine and then send the values back to the state of Florida. If the values fall outside the known range that the state of Florida has, but they don't tell you what those values are, I guess that they follow up by visiting that lab. So co-oximetry is also called hemoximetry, so it does mean the same thing. And it may be part of the blood gas machine, which it is for the ABLs. It directly measures hemoglobin. And the way that it directly measures hemoglobin is there's several different wavelengths of light that detect different types of hemoglobin. So there's a wavelength of light for reduced hemoglobin, another wavelength for the oxyhemoglobin, one for carboxyhemoglobin. What is carboxyhemoglobin? Carbon attached to hemoglobin? Carbon dioxide? Carbon monoxide is called carboxyhemoglobin, carbon monoxide. So the ISTAT, I guess we don't have to worry about that because you guys aren't seeing it. ABL 90 is what you're using. Okay. I don't know if you can see across the bottom, everything that's being measured with the ABL and it prints out. So CT hemoglobin is, I wonder what CT stands for. I know what F stands for. There's a whole bunch of F's there. And then your potassium, sodium, calcium, chloride, glucose, lactate, and bilirubin. So that's pretty good bang for your buck. Not only do you get your blood gas, you get an actual percentage of your hemoglobin and different hemoglobins and electrolytes. And what is the sample size? Like 2 mLs? How many mLs do you guys don't normally draw? 2? And on 2 mLs, you could run how many times? Oh yeah, that's right. So you scan the syringe with the scanner, and then you scan the patient's wrist or vice versa. So that attaches the blood gas that you just drew to the patient. And it's got some websites. To see a blood gas sample placed in the ABL 90, I don't think I need to show it to you because you guys are using it, right? Concentration, okay. Thank you. Total hemoglobin. Oh, you did? You are good at those manuals. Okay, so you can stop the recording on that.